So today we're going to be talking about section 2.3, and that is how to evaluate limits. Evaluating limits algebraically using algebra. Oop, I'm not writing in a straight line. And the limit laws. Okay, so before we get started with that, I just wanted to mention something. If you've got um, some values here for one function, let's say this is f of x and g of x, right? And you have, let's say 0, 1 half, 1, 3 halves, 2, 0, 1 half, 1, 3 halves, 2. And let's just put in some numbers. Okay, so we have a sequence of points here defining both f and g. Then, if you wanted to create a table for f plus g, right, the way you would do that is your x values would remain the same. But now, at each point of x, right, you go in and you add point-wise, right? So the first one would be 0 minus 1 would be minus 1. 1 plus 1 would be 2. Minus 1 plus 2 would be 1. 3 plus 3 would be 6. 4 plus 1 would be 5, right? And similarly, if I came in and took x and c times f of x, right, then my x's would stay the same. But now to find my new y's, right, I would go down my column of y's over here, multiply by c. Instead of c, how about 2? So then we'd have 0, 2, minus 2, 6, and 8. Good. And so on. So we might have f of x divided by g of x, for example. We would do that one point-wise. Okay, the reason I'm talking about these is because we want to take a look at two functions like this. So suppose we have let f of x and g of x be given, and we need an extra condition such that the limit as x approaches a of f of x equals L, and so the limit as x approaches a of f of x exists and is equal to L. And secondly, the limit as x approaches a, the same a, of g of x is equal to h. Okay, so if these two are true, then it's possible to say that the limit as x approaches a of f of x plus g of x is equal to, can you guess? Did you guess that it was L plus h? If you did, then you were correct. How about the limit as x approaches a of f of x minus g of x? Yep, L minus h. And the limit as x approaches a of c times f of x. Did you say c times L? So that's why we're thinking about this, right? If as x approaches a, c times f of x is just going to approach c times L, right? Let's see, some other ones. How about if you take the limit as x approaches a of f of x divided by g of x? What's that going to be? Well, that will be L divided by h as long as what? Can we always compute L divided by h? We need to make sure that h is not equal to 0. Which reminds me, I forgot one. How about f of x times g of x? If you multiply f times g, right? So remember, if you multiply f times g, how would you find it? Point-wise, right? You're just multiplying f times g. And so point-wise here, we're multiplying f times g. And so again, that would be L times h. Good. These are part of the limit laws that we're going to be looking at. And they're at the beginning of 2.3. Um, well, we'll see how those work in just a second, but before we do, there's a few definite computations I want to make so that we can do some other computations so we can see how the limit laws work. So let's do some specific limits. These are algebraic limits. X approaches a of c. Now what is this function? If you were to draw or form a table, what would be on your right hand side? C, 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 C. So therefore the limit as x approaches a of the function c is just c. And similarly, the limit as x approaches a of just x, now what would that be? Can you read that? That's a. And now the limit as x approaches a of x to the n is going to be a to the n. That's the power just carries right over. And we're thinking about, when we write this, right, we're thinking about n as being an integer. But it actually is true for other fractions as well. And then finally, if you have the limit as x approaches a and you want to compute it for f of x to the n, you could take the limit first and then raise it to the nth power. Okay, so using these properties, we're going to compute some limits. All right. So first one, we will prove using the limit laws. Whatever the limit is for the limit as x approaches 1 of 3x squared minus 4x plus 5. So we're going to do this one in a very formal way. Normally, right, this is a nice parabola, so you know that to find the limit, you probably just plug in the values. But we want to actually use the laws that we just put together, namely these and these, to see if we can prove it. So first, we're going to use this sum law to break the limit apart. And so that's going to be the limit as x approaches 1 of 3x squared minus the limit as x approaches 1 of 4x plus the limit as x approaches 1 of 5. Okay, and now this is a constant times a function, so you could just take the constant out, and that would be the limit, 3 times the limit as x approaches 1 of x squared minus 4 times the limit as x approaches 1 of x plus the limit as x approaches 1 of 5. Okay, now we can, now we're ready to use our laws. 3 times 1 then minus 4 times 1 plus 1 squared. I should be explicit there, plus 5. Very good. So minus 1 plus 5, 4. Good. And so you can see, right, we could have really just skipped down and substituted the value x equals 1 into your polynomial. How about the next one? The limit as x approaches 2 of x squared minus 1 divided by x plus 3 times x plus 1. We want to use the limit laws again to compute this, and then later on we're going to find a shortcut. So first of all, you can bring the limit into the top and the bottom using the limit laws. Good. And now this one you can break the limit apart, right? That's x squared minus the limit as x approaches 2 of 1 divided by, this is going to be a product of two limits, the limit as x approaches 2 of x plus 3, and then you're going to have the limit as x approaches 2 of x plus 1. Good. And now, just to finish that off, right, you're going to have the limit as x approaches 2 of x squared. That's going to be 4 minus 1 divided by. We could pull this in one more time, but I think you're getting the idea here. So that's going to be 2 plus 3 is 5 times, and then the 2 plus 1 is 3. Good. So that's going to be 3 over 15. But I'm losing my ink. 3 over 15. Please simplify your fractions. That's 3 over 3 times 5, right? And so that's going to be equal to 1/5. Good. So again, if you wanted to take a shortcut from here to here, you see that we could have just put in the number 2 in for x and gotten the right answer. Okay? And so that suggests a theorem, and we will be talking about that theorem in the next video.